Is it really true that everyone would buy from whatever firm had the lowest price, even if that price was only undercutting its rival firm by a tiny fraction of a penny? Probably that's not the case. Okay, so first of all, I don't think that people actually view these products as perfect substitutes. Okay? Take, for example, Coca-Cola and Pepsi. In blind taste tests, they've actually shown that most people cannot tell the difference between the two. Yet, a lot of people keep having strong preferences for one or the other. A lot of people are willing to pay more for Coca-Cola than Pepsi, and for some other people, the opposite is true. Some people are willing to pay more for Pepsi than Coca-Cola. Okay? So you have to think about whether it's reasonable to think that if Coca-Cola undercuts Pepsi by even a tiny fraction of a penny, that they would steal all the sales. It's probably not true. The other thing I wanted to point out is with search costs, it's not clear that everyone would know exactly who has the lowest price. If one firm undercuts the other by a fraction of a penny, how many consumers are aware of it? If not all consumers are aware of it, then again, Coca-Cola is not stealing all the sales. So whether it's for differentiation or search costs, if a firm is not stealing all the sales by lowering its price, then it doesn't give it quite as strong of an incentive to do so, right? If we think about it, in the classic Bertrand duopoly case, if one firm cuts their price to just below the other firm's price, by a fraction of a penny, they steal all the sales. Huge incentive to lower price just a tiny bit below your competitor. But if that doesn't happen, then there isn't as large of a profit gain from undercutting your rival, and there's not quite as strong of an incentive to do so. Okay, so that's a case we're going to look at next. We're going to assume that products are differentiated. So how do we solve this type of problem? Well, it's going to be similar to the Cournot model. In the Bertrand with differentiated product case, that is price setting oligopoly with differentiated products, we're going to assume a slightly different set of assumptions that they're setting price, but it's still the same solution strategy. Okay, so we're going to find the price that maximizes a given firm's profits as a function of the other firm's price. That's going to be the reaction function. We're actually going to find that for both firms, and then we're going to find the set of prices that satisfies both sets of reaction functions. That is, we're looking for the Nash equilibrium. Okay, so let's go over a particular example. Here we have a demand function for firm 1 and firm 2. So note the demand function for firm 1 is decreasing in the price that firm 1 charges and increasing in the price that the rival firm charges. And for the second firm, we're going to assume it's a mirror image, that the quantity demanded for the second firm is 12 minus the price that it charges plus the price of the first firm. And we're also going to assume that costs are 0 to simplify this problem. So then to solve it, we're going to go through a couple different steps. So first, we're going to find firm 1's reaction function. Then we're going to find firm 2's reaction function. And then we're going to find the set of prices that satisfies both reaction prices. Those are going to be the Nash equilibrium prices that we would expect to arise in this market. Okay. Okay, so the first step of solving this problem, like pretty much all of our problems, we have to write down the profit function. Usually the mistake that students make is they don't write down the right profit function. Okay, so let's try writing it down here. So the profit for firm 1 is going to be equal to its price times the quantity that it sells. Usually we'd subtract off the costs here, but the costs are 0, so we don't need to subtract costs from revenues. Okay, now let's get back to what I was talking about a second ago. Usually we substitute in for price when we're solving a lot of problems, but here what the firm is charging is price, and so it's a little bit more intuitive to actually plug in for the quantity that it's selling. We'll plug in the demand function for firm 1. Okay, and doing that leaves us with P1 times quantity, which is equal to 12 minus P1 plus P2. Again, there's no cost, so we don't need to subtract off the cost here. Okay, so now we have the profit function. So what do we always do when we have the profit function? Well, we're trying to maximize it. We know the maximum occurs at the point where the derivative is 0. So we're going to take the derivative, set it equal to 0, and solve. And that's how we're going to get the reaction function. So what do we take the derivative with respect to? We have two variables here, P1 and P2. Okay. Since we're maximizing firm 1's profits, we're going to take the derivative with respect to P1. Okay, so let me do that. So we're going to get partial derivative of profits for firm 1 with respect to P1. And that's going to give us 12 minus 2 times P1 plus P2. That's the derivative. We set the derivative equal to 0. Okay, so now we're just going to simplify this a little bit. I'll ask you, what are we solving for, P1 or P2? Well, since we're maximizing firm 1's profits, we're going to solve for its strategic decision variable, which is its price. Solve for P1. Okay, so we could add 2P1 to both sides, which will give us 2P1 is equal to 12 plus P2. And if we divide both sides by 2, we get P1 is equal to 6 plus 1/2 P2. Okay. And so that is half the problem. We solved for firm 1's reaction function. Okay, so this is firm 1's reaction function. So the next step is to solve for firm 2's reaction function. So that's the second firm's reaction function. Now I want to pause for a second. If you look at firm 1's reaction function and compare it with firm 2's reaction function, you'll see that they're mirror images of each other. And the reason that this is that always happens when the demand functions for the two firms are mirror images of each other and they have the same cost function. Okay. So that will always happen. You could actually skip these steps if you note that to be the case and just write down that the second firm's reaction function is a mirror image of the first firm's reaction function. Okay. So now what do? We have two equations and two unknowns. We want to find the set of prices where both reaction functions are satisfied. So we have to solve these two equations for the two unknowns. One way to do that is to plug firm 1's reaction function into firm 2's reaction function. Okay, so we could have that second firm's price is equal to 6 plus 1/2 times the first firm's price, where we know the first firm's price, according to firm 1's reaction function, is going to be 6 plus 1/2 times P2. Now, if you've noticed, now that we've plugged in, we have an equation that only depends on one variable. So we can solve for it and find the numerical answer. And if we do that, we'll get that, let's see, we can P2 is equal to 6 plus 1/2 times 6, which is 3, plus 1/2 times 1/2 P2, which is 1/4 P2. Okay, if we subtract 1/4 P2 from both sides, we get 3/4 times P2 is equal to 6 plus 3, which is 9. If we multiply both sides of this equation by 4/3, we get that P2 is equal to 112. Okay, so then you could plug into firm 1's reaction function. Remember that firm 1's reaction function is equal to 6 plus 1/2 P2, where P2 is equal to 12, so we plug that in. We get that P1 is also equal to 12. Right, 6 plus 1/2 times 12 is 12. Okay, so both firms are charging a price equal to 12. That is equilibrium in this market. And you'll notice that since the costs were 0, right, that means marginal costs are 0. So we have an example here, which is usually the case, where in the differentiated product price setting duopoly, that both firms charge a price above marginal cost. So just to summarize, we looked at a number of different oligopoly models. We looked at a couple of quantity setting oligopoly models, and we saw in those examples that price is greater than marginal cost. Then we looked at what happens when firms set prices rather than quantities, and we found that if consumers really view all products as homogeneous, in that specific case, we get that price is equal to marginal cost. But if they're differentiated, we then get that price is greater than marginal cost. So under most sets of assumptions, and I think under the reasonable set of assumptions, we get that in an oligopoly market that prices are above marginal cost.